Hi guys, and welcome to the series grade 11, 2015 paper 1. Basically, we will be putting up videos for revision purposes. Guys, past papers are not there to teach you the content. They are there to help you revise, to test yourself, assess yourself if you know your work. So this is for term 1, okay? So I'm just going to focus on the topics that are supposed to be covered in term 1. So in this case, for this paper 1, it's just going to be question 1 and 2, all right? So of course, in paper 2, we have spoken on Euclidean geometry. The videos are up on the YouTube channel, and you can have a look at that. So definitely by November, all the videos will be up relating to the different past papers from 2015 to 2019. Right, so let's look at this one here, starting with question 1. You're supposed to solve for x in each of these. And of course, the first one will always, they will start you all easy as a nice warm-up for the rest that is about to come. So here, if we solve x squared plus x minus 12 equals to 0, then we know this thing should factorize into x minus 4. And I think x plus 4, okay, rather not x minus 4. Let me just erase that. Yes, x plus 4 into x minus 3 equals to 0. And so we know there's a product. So one of these things has got to be 0 for this equation to be true. That is why we write the statement either x plus 4 is 0 or x minus 3 equals to 0, such that x now is minus 4 or x equals to 3. And you can see both of these are true, because if you put a minus 4 here, you're going to have a 0, and this is true. If you put a 3 there, you're going to have a 0, and that equation is true. So we accept both solutions in this case, okay? So moving on, we're going to look at this one here. 2x plus 1 is equal to x minus 1. Guys, now whenever you see square roots in an equation, there's a trap there. And the trap is that you guys, as you find your solutions, you are likely not to check the solutions. So please get used to this. Whenever you see the square root, in fact, when in all your equations, when you find your solutions, guys, do yourself a favor and check if your solutions are valid. Right, so here we know we got to square both sides. This is 2x plus 1. And I see a lot of weird stuff here. Kittens are being killed. People see this as x squared minus 1, or some even see it as x squared plus 1. Guys, please be mindful of the fact that you have to use FOIL when you get to this stage, okay? So you got to multiply this thing. You got to have x minus, you got to have this. Let me write this step here. Let me write this step here. You got to have that. Okay, and you got to simplify that, okay? So of course, I know there's gonna be x squared. X times negative 1 is negative 1. I times that by 2 is gonna be minus 2x. And then that's gonna be plus 1. And then you can see clearly now here, 0 is going to be x squared minus 2x plus 1 minus 2x minus 1. And clearly here, that 2x, does not cancel, but actually adds to minus 4x. 1 does take care of the 1. So if I simplify this, I can say, well, I have x into x minus 4 equals to 0. A equals to b means b equals to a, okay? Therefore, now here again, either x equals to 0 or x equals to 4. And you can see if you put 0 in your original equation, you're going to have 1 on the left side, and you're going to have negative 1. But 1 is not equal to negative 1. So this thing here is not a solution. Then x equals to 4. If I put 4, then I'm going to have square root of 9, which is 3. And 4 minus 1 is 3. So that is my solution. So, and that is how I conclude to this, all right? 1.1.3, we have 2. Now, it's very important to look at the notation here and how you interpret this. This is x times square root x is equal to 2 to the exponent 27, 27, yes. So obviously we know we can drop the bases because they are equal, then the exponents have got to be equal. So this thing is x. I can rewrite it as this. equals to 27. Once you get to this point, there are two ways to look at this thing, okay? You can either say, I want to get rid of the square root by squaring both sides, or you can either say, well, actually, this thing is x times x to the exponent half, and this is just 27. And you know this thing is going to be now x, okay? This is a 1 here. So you add up those exponents. I think you have 3 over 2 equals to 27. And if I want to get rid of this 3 over 2, I've got to do that 2 over 3, but I got to do the same thing here. Okay, so you can see now this all simplifies to x equals to, and I mean, you have every right at this point to go into your calculator and punch 27 to the exponent of 2 over 3. This is if you can't realize that 27 really is just 9 squared, okay, or it is 3 cubed. If you can't realize that 27 is cubed, is 2 cubed, is 3 cubed, or 9 squared, then really I give you all the rights to punch this whole thing in your calculator. You get that x is equal to 9. Right, guys, the inequality is quite straightforward. I'll write it down here. X squared minus 2x minus 8 less than 0. We have to factorize this into x minus 4 and x plus 2. I hope by now you have this well. And we want for the critical values, we see x is 4 and x is minus 2. So we've got to put our number line here, minus 2, 4. This is a parabola with a happy face. So I've got to now draw this up. It has to, so the critical values are essentially the x-intercept of your parabola. And there I am. And we look at the inequality sign says less than, and we know this is where the solution is going to be. Therefore, my solution here, in terms of the critical values, this is strictly less than, so there is no inclusion. So I'm just going to write minus 2 less than x minus 4. That is my solution. Very important to write it in this form. Drawing the graph does not really say much. It shows us, yes, you know what you're doing, you got a sense of what you're doing there. All right, that being said, moving on to 1.2.1, solve for x if f of x equals to 0. So you've got a quadratic equation here, 6x minus 7 equals to 0. But now, instead of bothering yourself with factorization, there's a hint that says correct to 2 decimal places. So this says, well, use the quadratic formula, x minus b plus minus square root of b squared minus 4ac over 2a. And I'm not going to insult your intelligence and substitute the stuff for you. So, and you know, you are the masters of that department. So that has been taken care of. The question that I want to look into here is really is 1.2.2, hence or otherwise calculate the value of d for which this equation here, 5x squared plus 6x minus d, okay, 5x squared plus 6x minus d is 0, will have equal roots. So we've got to think of the nature of roots. That's what we discussed in term 1. The discriminant can be 0, the discriminant can be greater than 0, and the discriminant can be less than 0. We know here the roots will be real, but also equal. Here we know the roots will be real, but non-equal, not equal, okay? In fact, they will be even, we will even have rational roots here. Here we know we will have non-real roots. That's one thing that we know. So which case do we want here is this case where the discriminant is 0. So we're gonna go ahead and solve that equation. So we're gonna solve the discriminant. We know it's b squared minus 4ac. And what is this? This is going to be 6 squared minus 4 times 5. Notice that my c is minus d, guys, the negative d. This is 36 minus 20d. In fact, it's going to be a plus 20d there. And so I want this thing to be equal to what? 0. So if I solve the equation here, I have 20d is minus 36. And so d is minus 36 over 20. And of course, you can simplify this by just punching that whole thing in your calculator. You get negative 9 over 5. All right, that is how straightforward this question was. Of course, if you had no idea about nature of roots, it would be a nightmare. The last one, of course, the simultaneous equations, xy equals to 20, and so that's equation 1, that's equation 2. Guys, really what you don't have to always make y the subject of the formula, okay? So what you want to do here, you want to avoid fractions. So in whatever you decide to be your subject of the formula, you have to avoid fractions. And can we avoid fractions here? Yes, in some cases we cannot, but in this case we can. So it is best to make x the subject of the formula in this case, okay? So that's equation 1.1 because I derived it from 1, and then I'll then substitute in 2, okay, sub 1.1 in 2. What do we get now? We have minus 3 plus 2y times y is equal to 20. This thing here is minus 3y plus 2y squared minus 20 equals to 0. Now I have a quadratic, which you can, of course, go ahead and use your quadratic formula. But of course, if you do know your story when it comes to factorization, you can see that this thing here is going to be 2y into y. From the factors of 20, we have 1 and 20, we have 2 and 10, we have 5 and 4. And you would have tested, seen that 1 and 20 is just out, 2 and 10 is out, and the best option is 5 and 4. And in this case, it is really better I put my 4 there so that I have an 8, and then I put my 5 here. 8 minus 5 will give me a 3, and I want the 8 to have the sign of the middle term, so I'll have a negative there and a positive here. Remember, this is an equation, and therefore y is minus 5 over 2, or y equals to 4. Then, of course, I substitute everything in that equation 1.1. So if y is minus 5 over 2, then x is minus 3 plus 2 into minus 5 over 2. This takes care of this, and so x is a negative 8. And in the same respect, if y equals to 4, then x is minus 3 plus 2 times 4, and this is basically 8 and then minus 3, which is 5. So you got a pair of solutions here, which of course you can try convince yourself by testing them into those two equations and see really if you're gonna get that. And I'm sure you can see that really 4 times 5 will give you 20, and then if you're gonna say minus 5 over 2 times minus 8, you can also see that you're gonna get a 20 from that. And so if they pass in one equation, they should definitely pass the test in the other equation. That's about it, guys, from me in this respect of revision. Cheers.